is actually the test plan and talk about test cases. Now, this is an important topic, especially when you talk about software development. When you have requirements that deal with your software at any particular level, CSCI, CI, functional requirement, or what have, it's important to actually test those requirements, see if you're actually meeting those. So what I've done, I've actually pulled up the IEEE 829 format of a test plan outline. And this is an outline that can be used to actually develop your test plan for your software requirements. So in here, in the test plan, you'll see that there is an actual test plan identifier, references, section for introduction, the test items, the software risk issues. Now, the other day we talked about actually capturing risk. Now, these actual risk issues should also be captured from the software as well. So for an example, if you have an issue that maybe there is malfunctioning code, or you're having issues with APIs or being able to integrate it with another application or legacy system, then that is a software risk issue that needs to be documented and assessed. If it's a high, medium, or low, is the risk actually going to happen? And then look at ways of actually mitigating, avoiding, or accepting that particular risk. Features to be tested. So what features are you actually testing? Remember, software tests can be very extensive. And if it's very extensive, it can also be very expensive. That's the thing about what features are you actually going to test when you're doing your test plan. And then features not to be tested. So if you're going for various accreditation certifications, well, various certifications for your particular software, it is important to understand what you're testing and what you're not testing, or what features. So when you're touting your actual product, hey, we have this best product and product A does X, Y, and Z, really, what did you test that product for, right? So you tested maybe for security, but functionality, you didn't really test for functionality, you only tested for security. And then you have remaining test task, the environment needs, what is your test environment? Staffing and training needs, responsibilities, schedule, planning risk and contingencies, approvals, and then of course the glossary. And so we'll go down here. And so here just shows basically the test plan identifier, just a unique company identified number to identify the test plan. This test plan is associated with whatever project or program or product. And then there's an identifier basically to say this is, what this actual item is referencing. And then in terms of the references, these are all the other documents that, are feeding into this particular document. So if you're talking about testing a particular requirement, an individual may need to actually look at the systems level design document. What are the test standards and procedures for that organization? That needs to be referenced. Requirement specification needs to be referenced. What is the overall project plan, right? So you have this test plan, and you're saying you're going to do this test plan in 2-3 weeks. Okay, well, what is that test plan, that schedule for that test plan? What happens if that test plan shifts to the right? What happens if there's scope that's increased for testing and things of that particular nature? So you really need to understand the project plan as a whole. And then you need to understand corporate standards and guidelines. So these corporate standards and guidelines affect what you can do as an engineer, right? You have to make sure that you're meeting the guidelines of the organization. So the introduction is just, what is the purpose of the plan? What are you doing at a very high level? And so think of it as an executive summary or an abstract. All right, so test functions. This particular item here, all it says is you're just talking about the items that you're intending to test within the actual scope of the test plan. So when we talked about kind of software engineering and systems engineering or project management or program management, remember scope, schedule, cost. So it's important to scope everything that you're doing. What are you getting paid to do? So here you need to outline what's actually the scope. All right, software risk issues. And so this particular portion, you're going to identify what software needs to be tested, and then what are the critical areas. So here are some of the items: delivery of a third-party product, new version of interface software, complex functions, safety, security, impacts to the client, government regulations and rules. That's important if you're doing federal government. You may have to do DICAT, which is Department of Defense Information Assurance Certification Accreditation process, or whatever the new process may be, a NIST-related process, that you may have other items that may affect your actual testing. It may affect the environment, the tools that you can use, and then the way that you actually have to report that data and then maintain that data, maybe for security or just proprietary information. All right, so what features are you going to be testing? So this is just all the features that you're going to test. All right, so every feature that you're going to test needs to be identified in this section right here. The next section, you're going to identify the items that do not need to be tested. And this is important. So when you're talking and touting your project, here you can actually say, okay, well, we tested for this, we're doing great on these features. However, there may need to be a risk associated with some of the features that we did test, right? Maybe the stakeholders don't feel like it's as important. Okay, maybe they're not upset with a few minutes latency within getting the data or things are of that particular nature, then it may not need to be tested. And then approach. This is basically the overall strategy for the test plan. So is there any special tools? If you're doing a test plan, maybe that's network based, you may need to run like Wireshark. You may need to run some pen testing tools with Kali Linux, some of the tools that are associated with that pen testing distro. Then essentially configuration management, how is that going to be handled? That, again, that deals with business policies. If you're a CMMI level 3+ organization, it has to be a well-documented process. There needs to be the QA person needs to come into the actual testing events and actually document what has been tested, the version control, things of that particular nature. How many different configurations are going to be tested, right? So now you're doing it because when you test something, you're basically saying, all right, this product is good and it's good for version 1.3.4. Now 1.3.5 may require an additional maybe 30% of the changes need to be tested, right? But if you're at 2.0, now you need to do a whole new test from scratch to ensure that this particular configuration of the software is okay for use. And then you have combinations. So maybe the software needs to run on a particular set of hardware or other vendor packages to certify it as a working particular platform. And then regression testing. Basically, if there's defects detected, what type of regression testing needs to be done. And then there's special requirements. Only if the full component can be tested. A specific segment or grouping of tests or features need to be tested together. Right, and then here you have Mtbf, which is mean time between failures. It's just a valid measurement for the test involved and that the data is available. You have software reliability engineering. So you have that, and then there's a few others as well in terms of testing. Then you have pass-fail criteria. So what is your pass and your fail criteria? Now, this is important because a lot of times organizations, they may test a particular software application. They may say, well, it works, but we're going to pass it, but truly you failed it. So you need to upfront set standards for what features need to be working for this actual software application to be approved. Then you have a master test plan and a lower test plan. Think of this as a system, subsystem, or a parent-child test plan that talks about how these various items can be tested. All right, so here you have suspension criteria and resumption requirements. And so say that there's a certain number of defects that have occurred, and you say if we get 20 defects on this particular software application, we need to stop. Then that is the point where you stop all testing because you've realized that you're wasting resources, whether it's time, money, and people, to do testing for something that's obviously not ready to go to this particular step. So then you have to go back within your development and do some re-engineering or do some re-engineering to make sure that particular item is going to be working okay. Then you have test deliverables. So, what are the test deliverables that need to be part of the plan? Test plan document, test cases, test design specifications, tools, simulators, static and dynamic generators, error logs, execution logs. So if you're doing testing on an application to see if you can log into it or if there's logs. So maybe you have a particular software that is keeping track of all individuals that log into that particular application, then you need to deliver those logs as part of the test deliverable if it calls for that. And then you have problem reports or corrective actions. Other test deliverables that aren't mentioned here are actual white papers. So maybe your test method is actually an analysis, so you have to deliver that white paper. So you may need to do that. So we'll talk about the 4 methods of testing, but depending upon the method that you're actually going to test that particular item, that will also drive the type of deliverable that you need to provide as well. Then remaining test tasks. So if it's basically if it's multi-phase process, say that you have groupings of various applications that you need to test. You have a spiral or something like that. You have the first spiral, the second spiral. Then you may be you're just taking a larger test of systems. Really, it's more of a systems viewpoint, and you're saying, all right, this subgroup A, subgroup B, these are getting tested, and then later we're going to phase in subgroup C and D as they're being developed and being ready to be added to the overall system. And we're going to go ahead and test these items separately, rather than waiting for subgroups A through D to be completed to deliver the entire system. So at least you can have the testing done in a system viewpoint where you can still meet actual needs of your customer by getting them something that is functional and tested and secure before delivering the entire ordeal. Because maybe these systems all talk together, and you can say, all right, well, we're going to limit the risk of the final deliverable by certifying these subsystems up front, and we will make sure that the remaining systems are working before you get those. Right, so you have environmental needs, and these particular needs are special hardware. Maybe you're developing it. You have a software application for an embedded system. It may only run a particular suite of hardware. How is the test data going to be provided? What type of testing is going to be done on each component? Special power requirements, specific versions of other supporting software. So, and it's also the same thing as OS, right? Maybe my software only runs on Oracle 9 or something like that. It doesn't work on any other versions, or it only runs on Windows XP. It won't run on Windows 7. So, what are those special versions of software that it needs to run on? And then supporting software, right? What type of Office suite software that this application may only run with, Messenger, things of that particular nature. And then what is the restricted use of the system during testing, right? So during testing, maybe you're locking down certain ports. You can only run certain commands. There's no updates being done during testing because of maybe the nature of the system. Then you have staffing and training needs. So what is the training for the application or the system? Are there any training for the test tools? And then responsibilities. Who's in charge is really what responsibility is. Who's setting risk, who's selecting the features to be tested, not to be tested, who's ensuring all elements are in place and being tested, who provides the required training, and then who makes the no-go decisions. All right, schedule. This schedule should be tied to your high-level schedule. So when you're developing your high-level schedule for your particular project, it is critical that you tie in your test plan schedule with your overall schedule. So if something happens with your test plan, then your final deliverable needs to push out to the right. Right? So make sure you have slack in your schedule in case your test plan is not a go the first time. So you should always expect to have some type of hiccup, right? So create your test plan as tight as you can. And then from other events, if you're able to capture slack, put that slack back in the schedule and move those other events up. All right, so here, talking about planning risk and contingencies. Basically, if you have a lack of personnel resources when testing begins, you have multiple tests going on, right? So maybe subsystem A and subsystem B are getting tested at the same time, but they use the same hardware, software, and other associated tools, which means you may have to plan 24-hour shifts. Subgroup A works the first 12 hours, subgroup B has the second 12 hours. This is quite common in industry due to tool availability. Other items change to the original requirements or designs. So there's change to original requirements. Then the testing that you need to do needs to change as well. And so you need to look at if the requirements that you have are actually being maintained, and they will be what they should be. What they should be in the actual future. If something were to change, or the requirements are the same. Because if the requirements aren't the same, your testing it's just may not be no longer applicable. And then of course, you're doing 12-hour shifts. You got to say, okay, well, they change or something like that. You need to look at team morale and the test, test perform, will it be reduced? I mean, there's a lot of things that you as a manager need to look at as well with the team. Approvals, basically who can approve the process. So you need to document all approvals. They need to be documented, sign-off sheets after the test, and we'll go through some of these items they show you as well. And so here, what they have here, this is a PDF, but you can use Libre Writer, and you can actually take this and you can open it up, and it will convert this from PDF to a open office document, and then you can actually use the sample master test plan. And you can see here they kind of got some items written out, so you can kind of say, okay, this is what they're doing. So when I'm doing my actual project, I kind of have a general consensus of what needs to be done in order for my project to actually work. So that's all you see here. Now, what we're going to do now, I'm going to show you an example of a acceptance criteria plan. I'm going to pull that up. So you can see me again. It's glad to see you guys. So I'm going to reschedule, not reschedule, but I'm going to reshare my screen. And I'm going to show you an acceptance criteria document. And so what you see here is the acceptance criteria document. It's a little bigger. So it shows the tester, the product, the assumptions, the build number. That is the number that is referencing your actual software application. So what is the associated item? And so you have that, and then you have your functional areas, IDs, the business rule, pass, fail, and then details. So you have this item, and there's yet another application as well, document, and it's just a test case. I'm going to share this. And so the test case, just an example, and so I'll provide this to you guys. And this is essentially how you write the test case, and these are all the steps for testing. So when you actually give someone to test your actual application, these are all the items that you need to have associated with it. So the priority, the test suites, the software hardware require, and then also steps and sub-steps, so that individual who's performing that actual test can perform what is needed. And that is pretty much it. Now, in terms of testing, you have 4 different ways: inspection, demonstration, test, and analysis. Inspection is the observation of using any of the senses to actually see what is going on with that particular test. You have demonstration, and basically this is the actual operation of an item to provide evidence that it accomplishes the required functions. And then you have test, and then test is essentially the application of scientific principles and procedures to determine the properties or functional capabilities. And lastly, you have analysis, and this is basically the use of established technical or mathematical models, simulations, algorithms, or other scientific principles and procedures to provide evidence that the item meets the stated requirements. So these are all the items that you can do to actually for your testing, to actually test your requirements. And so that is what you will actually need to do in your assignment, detail which one of those 4 items that you're actually going to use. It's a pleasure to have you guys listen to this particular chat, and I'm going to post this so you guys can have this chat for doing your testing requirements and your test plan.